During heavy departure periods at busy airports, runway demand can often exceed the airport's capacity. The result is usually a long line of aircraft waiting at the end of the runway. Every time those aircraft spin up their engines to inch forward, they burn fuel, release carbon, and waste money. To help find a solution, the FAA is field testing a NextGen concept called Collaborative Departure Queue Management, or CDQM, at Memphis International Airport. The idea is for flight operators and air traffic control to share information and monitor demand so that when necessary, taxi operations can be metered, meaning controllers restrict the number of aircraft that can push back into the active movement area during a set period of time. Metering enables the available airport capacity to be shared equally.
So now instead of pushing an aircraft back right away, we're actually holding an aircraft at a gate, saving fuel.
The aircraft will be sitting at the ramp already in queue, but in a virtual queue. They won't be burning fuel, they won't be wasting time out on the taxiways clogging up the intersections.
To facilitate data sharing, the agency installed a prototype service decision support system in Memphis and loaded it with a software application that processes information provided by flight operators and air traffic control.
The tool takes the information in from those inputs and runs a series of algorithms to determine the capacity that's available at each of the runways, and then determines, with the number of aircraft that are going to be coming out, a balance between that capacity versus the demand that's going to be placed on the runways.
If the application determines that demand exceeds capacity, metering kicks in. Based on the information provided by CDQM, controllers allocate to the ramp tower a maximum number of departures per 10-minute window.
Where in the past, where we would have done that manually, and controllers would have been labor-intensive, keeping strips and placement, who's number one, and all that's going to be taken care of with the computer and with software and the technology.
Initial results indicate that data sharing and CDQM hold the potential to reduce annual taxi-out times by 5,000 hours a year at Memphis, benefiting both the environment and the airline's bottom line. There are other benefits. CDQM makes it easier to move a priority flight to the front of the line.
So if they have a flight that they know that needs to get airborne because of connections or because of cargo that needs to make its delivery, they're in a situation where they can make that choice and get those aircraft airborne more quickly.
The next thing is capacity, because if you get the aircraft to the end of the runway in the right order, you might be able to create departure capacity by spraying the departures off the end of the runway.
Fewer aircraft in the active movement area means greater safety. CDQM also makes it easier for an aircraft to return to the gate if it looks like the delay is going to exceed the federally mandated 3-hour maximum. The next challenge is to apply lessons learned in Memphis to other airports, such as Orlando, where CDQM is also being demonstrated.
So we have a saying in the industry that goes like this: once you've seen one airport, you've seen one airport. So Memphis is not JFK, and JFK is not Orlando, and Orlando's not Denver. And so our challenge going forward is to take the lessons we've learned from this project and try to apply it to any other airport in the system.
If CDQM continues to prove successful, the technology will be integrated into the NextGen tower automation system. For more information on CDQM and other NextGen programs, visit the NextGen website at www.faa.gov/nextgen.